don't share your screen beside the resource person. If you share screen, then it will remove you. So if you are sharing the screen, then it will obstruct the resource person presentation. So be as a researcher, as an academician, or as a student, be honest with this kind of activities. And thank you, madam, for your cooperation. Now, uh, now, on behalf of IPREMS, I welcome Professor Subudhi Sir, one of the esteemed resource person of our workshop and one of the esteemed um, resource person in the field of research methodology, not only in India, throughout the nation, throughout the international area. Professor Subudhi uh, is a senior professor of management with a total teaching experience of over 32 years. After completing master and MPhil degree in statistics, he completed PhD in management with senior research fellowship from CSIR. He is also an alumnus of IIM Ahmedabad. After serving Berhampur University, Odisha, for 21 years, he joined Fellow Institute of Technology University as a professor in 2006 and then came back again to Odisha in 2007 to join KIT University. He has published 9 books and over 70 research papers. He writes popular articles for newspapers. He is the former editor of journal like Management Research Journal, Berhampur University, Lisa Literary Magazine. Presently, he is the chief editor of peer-reviewed research journal, Parikalpana, the peer-reviewed journal uh, by the KIT School of Management throughout the 10 years. He has already supervised 9 research scholars. He has already got a PhD under his supervision. 6 more currently doing research under his supervision. He has presented 50 research papers, including 18 international conferences, and he is acted as a resource person for 30 UGC, AICT, IICR, CSIR, ICSSR, FDP's workshop, and is a well-known researcher in the field of advanced statistical research and empirical surveys. We are waiting for your presentation, sir, and it is up to you, and we are it's up to you, sir. You can take the session. Thank you, sir.
Good afternoon, Dr. Praveen. Thank you so much for this nice introduction. Is my screen visible?
Yes, sir, visible, sir.
Praveen, how much time I have?
And it's up to you, sir. If you can take how much time we are with you.
No. I should not bore the respected participants. Praveen, I have got a small request, and you please help me out. You have to tell me the timer, and if my screen is not visible, and if there is any question, we can take it up. No problem. Anybody can ask, and we'll enjoy interactive sessions.
Yes.
Is my full screen visible to all of you?
Yes, sir.
Thank you so much, Dr. Praveen and his beautiful wife and the entire team of IPREMS. I'm sure some of the participants are very senior researchers and my former colleagues. I don't know if Dr. Prof. Sir is also there. I cannot see and I cannot take individual name. And my regards to all senior scholars and my good wishes love to all young scholars. And I must thank Dr. Praveen for introducing me so profusely, but I would like to supplement. I I earn my bread and butter from Berhampur, so I owe a lot to Berhampur. So whenever there is a call from Berhampur, it's my duty to give back, and I participate. I really enjoy whenever there is a call, physically, virtually from Berhampur soil. Okay, as instructed by my dear Dr. Praveen, I have been given the pleasant task of telling you something about data analysis and hypothesis testing. And I'm sure the time given to me is max 1 hour, that is 60 minutes. So I propose to finish by 50 minutes, and we can have 10 minutes for open discussion. Hope Dr. Praveen will allow all the participants to ask questions, suggestions, or supplementing kind of thing. So here you go. The session plan, what I will be speaking for next 50 minutes is like this. As we are going to broad sections of the presentation, data analysis and hypothesis testing. So the key commonality is data. So we should have some quick review, quick recap on the data concepts, why we need data, what type of data, and how do we collect data. Then we'll be moving quickly to how do we analyze the data for our specific research. And second part will be hypothesis, and we'll be touching upon the concepts, applications, and we'll give a lot of examples today. I'll try to give some examples using MS Excel, and also try to give examples using SPSS. And of course, there will be some brief talk. Time permits, will be talking very briefly on validity and reliability. I request Dr. Praveen to share this PPT to all the learned participants so that they can go through the PPT data. And this is what I suggested. We'll have some numerical examples too. So to start with, as we all should appreciate for any research, or particularly quantitative research, data is actually the building blocks. We need to respect data, we need to understand value data, and we must start with every research, the need, the requirement of data. Do we really need data for a research? And if I need, why should I need? I should ask to myself. I'll be having few questions, some questions every researcher should ask to himself or herself. Do I really need data, or without data I can manage the research? I can give many examples. Without data also many research can be done. Particularly Dr. Praveen's father-in-law, in literature, a lot of research being done without data. So a lot of good quality research can be done without data also. So can we manage without data, or we need data, is the first question we need to answer. Then if you are convinced, yes, I need data, then what type of data? I think my predecessor, the previous speaker, was telling about the qualitative data, quantitative data. That's what I need to understand. And what is my sources of data? I cannot collect from anywhere. Okay. And then I need to know, how do I collect the data? What would be the methods of data collection? Then, as we all know, we need to have the measurement scales or the instrument which we measure and we convert it to data. Then I think my previous speaker was trying very briefly about the methodology, how do we conduct the research, designing the research so that we reach at our required data. So let's have a very quick recap on the types of data. I know that many of you know better than me. I won't be wasting your time. So as we know, there are two types of data, primary versus secondary data. I won't waste much time, as we all know. And that could be like another angle, quantitative or qualitative data, which we also call categorical data. Again, we also classify data into collected versus auto-generated or reported to us, automatically regenerated. We don't collect here. Now, there could be also another angle. Let's try to understand the different kinds of data that we can have. We need to do experiments so that we generate data. That is called experimental data. or we just observe, collect data like that, which we do in social science. And the last one is very interesting also to know, is it something like a random data or a purposive data? The best example, the latest example would be like say COVID patients. Okay, so we are not picking of randomly the samples and purposefully those who are having symptoms. So we are collecting and testing those persons only. So that is called purposive data collected from the purposive sample. Now, what we have discussed, I think there should be a feeling that data should be very, very specific to one's research objective, and which we really require it. Now, again, I will have a few questions which I request all scholars should ask to himself or herself. Do I really have some research specific objectives? Either we have objectives or research questions, or maybe like research issues. If I know the objective or question or issues, my problem will be solved. I know what type of data I will be needing. So objective is first. Don't go for the data first. Try to understand what objective we have for our piece of research. Then, do I have some propositions or hypotheses? And do we have some concepts, constructs, and operational value? Those are senior scholars. They may differentiate between these three terms: concepts, constructs, and operational variables. So the final thing is operational variables on which we try to collect data. I'll be giving sufficient examples. Don't worry. And for particularly for the young scholars, they can ask me also. Now, once we know these are my operational variables, then do I know how do I measure it? How best I can measure it? I could be having so many alternatives. So which one is better for me? We'll be giving example. Then, is it required? Is it necessary to have a hypothesis testing? And let me tell you, every research paper may not have hypothesis testing. So this is optional, but some research necessarily need hypothesis testing, and we have to be very, very careful and should be very clear also if I am testing hypothesis or validating any model. Then what we have discussed so far, it can be summarized that the research objective will perhaps decide the types of research, then type of research will decide the methodology, and all taken together will decide what type of data we will be requiring for our particular research. So this is the initial requirement. We should know, we should be clear what data we are analyzing, why we are analyzing data, then only go for analysis. Let's take a few examples. I think small examples I'll be giving so that it will be a bit clear for the young scholars. Say somebody had studied and found that elevation makes people more caring. Please mark the caption of this slide. Deliberately, I have put bold red on two extreme words. One side is elevation, another side is caring. I would say causal relationship, cause and effect relationship between elevation and caring. What the scholar has found, elevation means timely promotion in one organization. If one person gets timely elevation or promotion, then he or she in turn becomes more caring about the subordinates. So one is a result in another. So how do we measure promotion? How do we measure caring? I think the previous speaker was suggesting there could be some qualitative variable also. So I think from this example, we should understand if we are to measure caring, we are understanding that it is a qualitative variable, and I have to find some operational variable, how carefulness, caring can be measured. So this is something like a concept which can be defined in terms of some operational variables. Actually, this was like height or elevation and versus helpfulness or caring they found in a study. Okay, we'll be taking few examples, quick examples. And I request Praveen, please give me time indicator so that we can stop well in time. So the few examples are this: happy workers are most productive workers. As you can guess, this is something a finding, or can at least be taken as a proposition. Can we test this as a hypothesis? Now, if you can guess that what are the variables related here, I guess like we are perhaps trying to understand and measure happiness. Can happiness be measured? And it is to be compared with the productivity of that person or the worker. Now, the productivity, how do we measure it? So these are called some concept construct, and we need to define how this productivity will be measured. Okay. Now, next example, there is something like a proposition or statement or hypothesis. Elder siblings of family are more intelligent because maybe like they have got the additional responsibility of taking care of the juniors, so they are more like experienced, and I think there is observed that they are a bit more caring and they are experienced, so we can call it they're a bit more intelligent. Is it so? Is it true? Is it false? How do we verify this? So I think here one clear concept is coming at intelligence. If you are comparing intelligence of older child, younger child in a family, how do we make a comparison? So we need to measure intelligence. So I need to understand on which I want to collect it. That's what I'm suggesting. This is like a very interesting research. I think published research. I can circulate the article on the article here. Are women different than men? So this is something like a well research paper. I think it's very interesting. Social scientists will read this article. Next could be, I'll be discussing on this example. Conjugal happiness varies among actors. This is something like a very serious social science research concept. Conjugal happiness, please be clear, it is not only limited to husband-wife, it is conjugal means two. So there are two parties. It could be like teacher, student. If student is happy with the teacher, or employee, employer. So it's a co-actor relationship and happiness. So somebody has studied the conjugal happiness if it varies among the parties. I'll be giving example here. And here, the happiness, how do we measure it? Is it something like individual happiness or both the parties? Say worker and the employer, teacher and the student, husband and wife. I'll be giving example. And this also I'll be giving example. If we are getting a sound sleep, is it helping us doing our work better next day? If there is a sleep disorder, is it going to harm our effectiveness of work next day in our office? So how to do this? So how do I measure soundness of the sleep? And a concept could be like restfulness. How much rest we got because of this sleep, and how it is affecting our work life or work life balance kind of thing. Now here is one article I'll be taking example. Law has studied on the conjugal difference. As I was telling, they have taken different context. One like employee-employer context, their conjugal differences and conjugal happiness. And they have also studied about teacher students differences and happiness. And also they have studied about spousal relationship differences and happiness, the bitterness or the happiness in a married life of husband or wife. I'll give an example. Say, for example, we are doing a research on measuring conjugal happiness. Please think to yourself, how do we can measure happiness of two parties, husband and wife, in, for example, spousal relationship. Please see how the scholars have done. Look at here. Now, the data, as I told, that it could be different parties or the players. Here in the spousal relationship, could be like husband or a wife. To be simple. Now, let's see. I'll be taking, for example, only the spousal relationship. I can take like teacher, student, employee, employer, kind of thing. Just to make it simple, I'm giving an example. Please see. somebody how it has like observed this I have like borrowed. Now, suppose you are asking what is the impression of wife on husband. I think from picture you can understand. I think the message can like understand what is the comment of wife on like husband. Okay, and the same thing whether they are happy or there is a lot of difference between husband and wife. You ask the same question to husband, please see how husband perceives about wife. Now the real challenge is how we collect, how we like measure this. So this is a huge challenge of qualitative data collection. So we have to have certain robust skills of measurement. We will be discussing later. I'm just like showing the challenges of data collection. Yeah. Now, so for example, it's like slightly better where I have also done some work. Suppose you want to measure like which institute is better, how much is better. Say, don't feel bad if we are asked to compare with Berhampur University with Sambalpur University, or maybe like IIT Madras with IIT Bombay. How they compare? Say, for example, KIIT with ITR. So, for example, like this, or maybe like say I want to make some judgment like different scholars, researcher, a teacher with another teacher. How to do that? Now, there are a lot of research publications. Those who are interested can please refer. One of my, the question is how to measure and what to measure. This is like a real challenge. And this is what I will be summarizing. Any question? Naveen, any question? Okay. Yeah, it's okay. It's okay. Just like help me if I'm not audible, you have to like ask. So, what people have done, I'll be showing you something like a impact. Somebody has taken like the concept or construct as impact. So, like if the institute is doing research, how much IIT Kolkata is doing, IIT Delhi is doing or IIT Chennai is doing, what is the total impact or the quality of research? If you are like taking that measure, and how do we do this? And here is one of my research friend, Vires. So Vires, so he is from XIM Google. So he's a very good researcher from the economics area. He has done some work on the research productivity in management schools, particularly these schools in India. He has, as you can see the title here, I can share this article here. And please see, they have studied, compared all publications which happened from 1968 till 2015. You can imagine hundreds of articles what are published by different institute. They have collected, they have summarized, and they have developed an index. And they have given which is better and how much one is better. Okay, I was also trying in a small way to do it for my own research journal. Let me tell you that I am also editing the research journal of IT University. So for my editorial, as a small piece, I was also trying to understand, can I compare different institutes? I was like trying to compare different institutes of India. So one can ask like, how do you compare? So like you have got different scores available in Google Scholar, ResearchGate. What I did, I took from Research Scholar, the scores are here. I observed every fortnight. As you can see, I was taking the total scores on the top Asian institutes and top Indian institutes, like how they grow. Like say, you can like see the last column is my only contribution. These are the collected secondary data, and the last column, like say for example, one is number two. Can it like beat number one? Because you can see the number one is growing at the rate of 15%. So it is difficult to beat. So if you want to be number one, you need to grow faster. So similarly here, say Indian Institute of Science, which is a top research institute in India at least, and it is ranked in top 100 in the world, like it is growing at like 14.3%. So if you go on observing the research strength, this is the total citation of the total journals, articles of all scholars and professors. Okay, so this is what like the score. So because I'm not like biased, I'm putting some source, and this is like verifiable. So one can challenge how you have compared this. So like this is what like the basis of data collection, so that it is accepted by many. This is what I'm suggesting. Say, I have got a purpose, I have got an objective. Then I decide how do I collect the data. So this could be secondary data, primary data, and in primary data I can have quantitative or qualitative data. That's what I'm giving through examples. Moving forward, let's try to give, I suggested that we'll be trying to give examples of operational research variables and how do we measure this. Yes, I was wondering, it came to my mind some 2 years back. Actually, can I do some research like if we are not getting a good sleep, is it going to affect our next day's work? So I was wondering, sleep must be qualitative variable, and I don't know. I'll be asking just the respondents whether you had good sleep or not. Then only when my colleague suggested why you are making it qualitative when it can be quantified, I was not knowing because I'm an old man and the colleague is a young man, and many young friends must be doing there is a app called Fitbit when you're putting on your wrist, and it is linked to the mobile app, and it measures how much you have slept, how good you have slept, and it is quantitatively measuring it. Then I told you, wow. So when I know that a variable can be measured quantitatively, nothing like it. So like say my colleague that day on 25th August 2018 slept total 7 hours. As you can see, the deep sleep, red eye kind of thing, you can understand here. So I can have a quantitative data on sleep also. I'm measuring one instrument like this. So I need to know. I think somebody was suggesting about the review literature, what is existing. So I need to know if it can be quantifiable variable or not. This is what I example here. So having said this, what we should understand that we really need some good and appropriate data. Not only good data, it should be appropriate data applicable to our own particular research. And we'll be trying if it can be quantified. So as we all know, just to measure, we need scales. I'll not be taking much time. Maybe some other speakers must be covering this. And we know some of the known scales are like this: nominal, ordinal, interval, precious scales. But all of you should understand the scales of measurement and the instruments. It has to be robust one. Robust means, and it should pass the test of validity and reliability. And if you kindly permit, I'll be quickly running through the requirement of validity, reliability of scales, and which you can also call instruments. Very briefly, we can say the reliability is one. If you repeat that measure, it gives you the same result, and it is very much consistent. Okay, and validity is something like which what it does what is expected. Okay, and it is because of that it is described in correct form. Okay, now I'll be skipping this. That could be internal validity, external validity, but I will be loving to this give example of rifle shooting so that it will be clear like what is the distinction between validity and reliability. I understand some of you are teachers. If you feel like you can give this example in your respective classes also. Please have a look at three pictures, A, B, and C. And we are comparing the reliability of the rifle and validity of the rifle. And the purpose of rifle, as we all understand, shooting the target. Target means bullseye. So here should be the bullseye. And please see, it is scattered all over. So it is not, suppose we are hitting once here, second time we are hitting here. So it is not reliable, or we can say low reliable. Okay. Now please look at here. Now there is quite precision, and it is hitting at the same speed, same spot. So if it is doing the same thing repeatedly, we can call it reliable. But as you can understand, we wanted to hit here, not here. So it is reliable, but it's not valid. Okay. So now please look at here, and the situation B is a new rifle, and it is hitting at the center, at the bullseye, also hitting at the same kind of thing, bearing some exception. So this is reliable and also valid. This is one example one can like keep in mind regarding the validity and reliability of instruments. Okay, there is some test of reliability. Let's skip this because we are to devote something on hypothesis, which is more important. And this you can please have a self-reading, and I know that many of you know better on this. This also I'm skipping. Yes, how to improve reliability of our, mostly we use questionnaires, and mostly if it is a unstructured, semi-structured questionnaire, its reliability will be less. And whenever there is a well-structured questionnaire, you can expect good, better reliability. And naturally, we need to have retesting or pilot study so that we can have some corrections, improvement. Now, here is what Dr. Praveen had asked me to cover on hypothesis. And here I'll be first covering on the basic concepts. Then we can take it off some examples, numerical examples, both in Excel and also in SPSS only example. I know that I have gone through your program schedule. Somebody is doing in detail SPSS. I'll not be going into this SPSS software, but I'll be repeating the output so that we save time. Okay. Now, hypothesis, as you know, that is a declarative statement about the population, and we want to test or verify. Okay? And we can also call it as a provisional answer to a research problem. I think Professor Adhikari was suggesting research issue and problem. So this can be taken as a provisional answer, and we need to check, verify whether it is correct or not. As we know that many hypotheses can exist for the same problem. Say, what is the cause of COVID kind of thing. So you have many alternatives. If it is so, then how do you do this? Now, out of the many hypotheses, as we know that traditionally we have got two. One what we tested, which is called null hypothesis, and denoted by H0, and it is tested against the alternative, which is called alternative hypothesis or H1. Now, here is something interesting. Allow to please mark it carefully. Actually, testing a hypothesis is something called sample testing. And some sample testing or testing of hypothesis can have serious fallacies, serious mistakes, which is called errors. Okay. Now, please see, this could be the situations. Now, say we are taking a sample and we are taking a judgment, and based on the judgment, we will be either rejecting it or accepting it. Now, please see, suppose we are taking a sample, and that sample we verify. Say, for example, a shoe or a chalk, whether it is a good quality shoe or a chalk. We take one and test it, we find that it is bad. So this is what we are testing only from sample. So we have to reject it. Now please see, we have got four situations here. Now you have rejected when it is actually true. Now how will be coming across like this? Say, for example, there is by chance a chalk, and you have got a moisture, and maybe like there was a raindrop and it was wet. When you are using on the blackboard, it actually didn't write properly on the blackboard. Then you reject it. Maybe it may so happen that that particular chalk was bad, but the entire lot was not that bad. It was good. So maybe like you have wrongly rejected this. So this is something like unfortunate error, which will be called a typo error. Now here, say for example that chalk is good, and actually the entire population or the entire pack is good. So you are accepted and you have done a good thing. It's a correct decision. Now please see, this situation, look at here, third. It is sample is bad and the population is bad, and you have rejected this. And last one is very interesting. All of you please see here. Now, what actually happens in this commercial world? Maybe there is sample medicines. Those sample medicines, maybe if it is good and if it is tested, those sample medicines alone are good, but the entire population may not be that good. as you can guess, like what happens in actually commercial productions like this in this very very fake world. So in that case, what happens when what is given to us, say sample medicine or whatever, then we are accepting it. Okay, and actually this is very very bad. I can give so many examples, and one of my close relation who is working in a like bulletproof jackets manufacturing unit, like something like the fiber they have manufactured. Now please see. So what happens usually in government sector, you need to give kickbacks, bribes, kind of thing. A lot of things happens. So there will be some testing of the bulletproof jackets. So those will be tested. They'll be giving very very good bulletproof jacket, and some inspectors will be firing, and they will be satisfied. Yes, this product is okay. When they are approving and the government okays, and God knows what is supplied again. So actually the quality may not be good, and what is shown to you based on that sample, you are accepting unfortunately, and that decision is wrong. This again is situation. So in testing hypothesis, we need to know, and these are two, type 1 error and type 2 error. And as we know that this is alpha, and this is beta, and 1 minus beta, as you know, that is power of the test. Okay, coming to the hypothesis testing in general. So what we'll do really, we have got some like observation, that is symbolically put as a D, and you have got some expectation. What you are observing, is it matching to our expectation? Observation minus the expectation, if the difference is significant or insignificant. So we test the significance of the difference. So that's why sometimes hypothesis testing is called test of significance of difference test. And this is a numerator, and because it varies from test to test, sample to sample, so we have to factor in the deviation, which is called standard error of t. Okay, this is what the general formula here. Okay, moving faster. So as we all know, we have got so many testing out of this formula. One could be large sample test, which we all know that is a Z test, and there could be like T test, F test, chi-square test, and so many other tests also. Okay, now these are the steps. I think we all know that there could be one tail, two tail test, and these are the critical values here, and we will be testing either at 1%, 5%. This I'll be elaborating a bit further through my examples. Okay, let's have a quick understanding notes on the importance of the p-value. I think many researchers are using p-value, that 1% alpha is actually the p-value here. Now p-value usually, traditionally, we take as 5%. If it is less, we call it significant. If it is more than 5%, then we call it not significant. Okay, this is what the practice. And this is what like the description of the significance of p-value. I think this is theory. We should avoid the theory. And this is what I suggested in the previous slide. It is actually the type 1, which we type 1 error, which actually we discussed in the last slide. Okay, better will be giving more numerical example so that it will be more clear. I guess we should discuss something about very briefly. What do you understand by a two-tail test? What do you understand by one-tail test? Accordingly, the critical region will vary, and those values will also vary, as you understand. Say, for example, we are testing a product like, say, our two-wheeler. If the two-wheeler, what is suggested by the company, is it giving that mileage per liter? Suppose if you put 1 liter, how much kilometer it takes of cost? Now, will be critical, will be unhappy. Critical means unhappy if it is less than the prescribed. Suppose company told it is 60 kilometer. If it is something like more than 60, okay, is fine. If it is much below 60, 40, 30 kind of thing, we are very much critical. So please mark here, some cases, some situations, higher is not bad. More the merrier. in that case, we should not go for two-tail test. We have to confine ourselves to one-tail test. Similarly, mobile battery life or our laptop battery life. If we charge it full and we are expecting that it will run for so many minutes or hours. Now, if it is high or better, if it is really failing before the given assured time period, then will be critical on our. So that example is also one tail test. And two tail test, I can give like say body weight or say rainfall. Say for example, if it is too less rainfall, this is bad for agriculture. And if it is too much rainfall, flooding is also bad for it. So too less bad, too high bad. So we have a criticality or critical region on both sides. So taking the examples, we should decide whether it is a one-tail hypothesis testing or a two-tail hypothesis testing. Similarly, we can take blood pressure, we can take body weight. If it is, we are like very, very less weight, it is not good. If we are like very, very heavy weight, it's also not good for our health. So this is what like we can say. So that falls into two-tail test. This is what like mathematically we can like explain here where we do for two-tail test. Usually, alternative hypothesis decide whether it is two-tail or not. If it is one side less, it is left tail test. If it is more right hand side, it is a right tail test. Both are one tail test. And if you are comparing not equal to, then it is two-tail test. Okay. This is what like the two-tail test criterion can be diagrammatically presented. So here the white area is okay, and if it goes beyond this, then we reject. That is called critical region, and it comes right tail and it comes left tail. Okay, and this area we accept. Now moving forward, first we'll quickly run through the concept of the test, and it's a small sample test, and there is a approximation assumption that we have to assume that it is behaving normally here. Okay. Now let me show you one example how if we get data, then how do we use either Microsoft Excel or SPSS. And for example, I'm just taking to save time, I could have taken 2-3 sessions. So like say sample independent group t-test. Okay. In that case, what do we do? Now we have to compare means of groups, okay, and whether there is significant difference between the means of first sample and the second sample. So it is a mean difference test or t-test. Repeat, mean difference test is called t-test. Now what do we have? Here is some assumptions for this, and the sample size may not be same. Okay, it will be unequal sample size. Now please mark the difference here, as I have already explained here. If the alternate hypothesis is mu1 not equals mu2, that means it's a two-tail test. Please all of you remember this. And this is something like optional. First, you need to know whether the variance of the two groups are equal or not, because you may not know the population variance. You can also do a test kind of, and that is called F-test. But if you are sure that you can skip this, better you can skip this test, directly go for T-test. Now these are the commands. You can please get it from this slide, and in Excel also you can run the F-test for the testing of equality of variance kind of, or else we can go for directly the T-test in Excel. So this is what we will be doing. I'll be quickly running through, and these are the commands for running a T-test in Excel. I'll be giving the data here. Say for example, as you can see, I'm giving a numerical data. So this is group 1, I have labeled 111. This is group 2, I have labeled 222. So if you get data like this, you need to put in Excel sheet like this. Group 1 code, group 2 code, and the values that you have got. Okay. Now these are the values I have got, and then there is command if you are doing it. So you get the output like this. Okay. Now this command I think can be explained by some speaker later. But more important, what I feel is the interpretation. If I enter data, I get some result. Then how do I understand what the computer has given me the output. Okay. Now, if this data is run, this is actual data, and the output from Excel I will be getting like this. So as you can see here, it is giving you the mean of group 1, mean of group 2, and it is also giving variance of group 1 and variance of group 2. You can call that it is significant. Significant means the difference is significant. Both mean cannot be same. You can see the mean and variance. I have copied here again. Now, for the scholars, suppose you are running it and you are writing one article. This output, how it should be written actually. There is a structured form. You all please note it. Usually in a standard article, if you know this, you need to write like this: as methods, as results, and these values you can tell. So first we have carried a test to show that it is not having equal variance. Then we are carrying out mean test, and it also found to be significant. That means both groups have different mean conclusively. That is our conclusion. Okay. Moving forward, chi-square test is a very, very popular test. I think many scholars use chi-square test in almost all research. It is most favorite for testing the dependence or association between two factors. And it can also be tested for goodness of fit and also homogeneity. But mostly the first one, testing, checking the dependence or association between two factors, two attributes, is actually calling for a chi-square test. Now, I'll be quickly running through. I'll be taking another 5-10 minutes, Praveen, if I am allowed. Then
yes, sir. No problem.
If you can open it for discussion, if you have questions. So I'll be running through very quickly how we can have outputs from SPSS software. I'll be quickly running through T and chi-square. I won't be devoting much time. But multiple regression, I'll be taking much time. Okay. Now here is what, if you enter data, two groups data, you enter this way, t-test, and the command is like this, and the output you will be getting like this. Okay. So this I'm skipping because t-test we have done in Microsoft Excel, and chi-square test, suppose this data you are, hope some of you must have run SPSS. I am sure I have seen the program schedule. Dr. Praveen has got special session on SPSS, and one speaker will be voting. So this is what we call data view mode. All data is entered, and in SPSS there is another mode which is called variable view mode. And if you run, and the output will be there, and you need to verify whether it is significant or not. Again, p-value. If you look to the significance here, you can verify the same rule. If it is less than 5%, then it is actually significant. So this is the last one, but I will be taking a bit longer, 5 minutes on multiple regression, where we can also have a test here. So this is what the variable view mode of the data. You can see here, one is called data view mode, another is called variable view mode. I'm very sure the speaker who will be devoting on SPSS will be telling you on this, what is data, how do you enter data, and how to define the variable here. There are two sheets in SPSS. Say for example, you have got data, you have run multiple regression, and you got this type of output. I'm sorry, I've taken a photocopy from a book. I'll be giving you a better picture next slide. So usually when you run SPSS for multiple regression, you get three distinct tables like this. One is called model summary. Please note. Second one is called ANOVA table, and the third and the last one is called coefficient. I'll be giving one example so that all of us will be clear, and I request you can ask on the next example. This is the example. All of you please see. I'll be giving you actual output which I had done myself. Say, for example, in one organization, particularly private industries, where longevity is an issue. How many years one will stay is a really great challenge. So the turnover, that is, or say like how many years one would love. Now, is it dependent on the education background? A scholar wanted to study. Is it dependent on the age factor? Is it dependent on the entry level entrance score through which we have recruited the person? Is it dependent on the family dependence? Now, a scholar had taken four predictors, which we call independent variables. Please, young scholars, participants, please look. I have got x1, x2, x3, x4, and versus y. You can imagine. So I have 5 columns data. Okay, and here I'll be having 10 rows of data that I'm not showing, and I have run in spaces. The output is like this. First, model summary. This is very important. How do we interpret? This is actually the R square is the key element to explain whether this regression model is really good or not. It is 0.87, means very, very good, 87%. The meaning here is, I can repeat if you ask categorically me after my presentation. So these 4 factors together explain up to 87% of the variation in a person's stay in one organization, or how long a person will last in one organization. So this R square is very important, and this is what called like unavoidable. Please see, here is F statistic value, and here is P value. The last value, P value, is important. As you can please see, this is 0.045. This is narrowly significant. Okay, and the last table here is the coefficient table, and the coefficient table is again you see individual factors. School factor, what is the p value? Age factor, what is the p value? Score factor, what is the p value? I guess like you understand like what are the kind of, is it like a significant contributor to contribute to the whether one is more likely to leave early one organization. Say, for example, here one can guess like the age factor is pretty significant. If one is young, one is like bubbling with energy, one is damn confident that like I'm like I can get any company kind of thing. So age is a factor. Now the education is not that important. You can see it's not a significant factor. And dependent, yes, like it has got this scope. So you need to know like if one is having a more dependent, he or she may not think of quitting the job very quickly because he or she has got liability. So that's how the person has suggested. Now, two things we need to interpret out of this kind of like test or another table. One is R square. R square. Another is whether it is significant or not. This p value. And last but not the least, we need to like explain out of these factors, which is really more significant contributor here. So this is what like we understand. So as promised, I think I have taken around 50 minutes. I guess like here we should have some questions, and
Yes, sir.
I would love to take up questions.
Sir, some of the participants ask question. Uh, First question is from Day1. Yes, last question is how to frame hypothesis for pre and post multiple response question in statistical test.
Okay, can you repeat the, I think you are not audible. Can you repeat the last sentence?
Sir, how to frame hypothesis? How to frame hypothesis for pre and post multiple response question?
Actually, I'm not getting the question. If I have understood the question, pre-response and post-response. Say, for example, experimental research. Say, for example, we are checking malaria. So, pre and post, if you want to like find the effectiveness of medicine, so whether there is any significant difference between the two, to my knowledge, here it is a like mean difference test and t-test should come in the hypothesis. Am I answering to the question, Praveen?
It depends upon the Nancy Gupta who is asked this question.
Yeah, you can enable speaker, please kindly enable, allow them so they can also ask directly. So that
she can enable. No problem. The next question, sir, from Kadambini Das. She has asked, is hypothesis testing a tool or a goal? Is significance level constant or changeable?
Okay, interesting question, Kadambini madam. Actually, p-value, as I suggested, it is not constant. Some senior professors, reputed professors, even test at also 10%. Actually, we cannot like do it at 1%, 5%, and there are like varying suggestion, prescription by different reputed scholars, very pretty seniors, like R.A. Fisher, like guru of type statistics kind of thing. So they have also given, you can actually Google and refer wiki also. So that would answer that it is not fixed. And I think that it is second bit of the question. What is the first bit? Sorry, I forgot.
Regarding Kadambini.
She had actually two components in our question. Second component I have answered. It is not fixed.
Is significance level constant or changeable?
That is answered.
Is hypothesis testing a tool or a goal?
Okay, this question actually you don't want to answer. So it is actually a goal. You want to like actually have some objective and it's a goal and you want to verify that. It's not actually a tool. Tool is something else. Hypothesis is just a statement. As I have suggested, you have got different tools like t-test tool and others kind of thing. Hypothesis is just a statement, statistical statement. It's not a. Next question.
Next is Litton PM. He has asked, so what is the difference between one sample and two sample t-test?
Okay. And actually, we have got paired t-test, and paired t-test is actually when you have got equal sample size of first sample and second sample, and two sample varying sample size we have shown today, and single sample also you can also check if you have got two groups also in the same sample. Next question.
Suman Debrapalli asked that how can I develop testing hypothesis on integrating reporting with reference to Indian context?
Can you please repeat again? Actually, the voice is not clear.
Sir, how can I develop testing hypothesis on integrating reporting with reference to Indian context?
Why don't you allow the speaker so that he or she can enjoy, so that he or she can really produce. Suman D, you
yes,
can
sir,
ask me.
Yes, sir, this is Suman D. Hello.
Please tell. I can hear.
Yes. I'm a research scholar from SRM University, recently joined. So my work is hello.
Hello. Please tell.
Yes, sir. my topic, I have chosen a topic, integrated reporting and its impact on Indian economy or financial markets. So I started reading some articles, and I have not found any research work is done in Indian context, and it is moreover from the South Africa.